All right, so now we're going to continue on. We're going to find the areas now that we've named some of those properties of regular polygons inscribed in circles. Now, again, down here is just the formula, but I want us to understand where it comes from. So if they want us to go ahead and find the area of any regular n-gon divided into congruent triangles, it's really pretty easy. And if I use this picture down below, we have this hexagon. There's 1, 2, 3, 4, 5. Remember, that's a whole 6 triangles, which is what it should be. It's a hexagon, so 6 makes sense. All you have to do is find the area of one triangle and then multiply it by 6, right? Multiply by the number of sides there are. So that's what they say here. The area of one triangle times the number of triangles that you have, which is the same as the number of sides you have. So there's actually, they present another formula, and again, sometimes people see these and they think, where did it come from? So let's just see how they relate. So if I have this scenario over here, if I find the area of one triangle, it's going to be 1/2 the base, so 1/2 of S times the height, which is A. 1/2 of S times A, and they put that in parentheses. That's the area of one triangle. Now, n is our number of triangles because it's an n-gon, so that's why they multiply by n. Now, using the commutative and associative properties, they go ahead and they group the n and the s because it's all multiplied, so I can do that. They group the n times the s, so they bring this s over here. And then n is the number of sides we have. S is this distance. What is n times s? That's really just the perimeter of the entire polygon. So they replace that with capital P. So I personally, anytime I'm given a problem like this, I don't, because this one isn't in my head, I go ahead and I find the area of one triangle and I multiply it by how many triangles I have because I can understand that. But if you're ever given this formula, okay, again, I'm thinking of like standardized tests or some scenario like that. I want you to understand why it also works, okay? All right, and again, A stands for the apothem. So you can use either one, and we're going to kind of work through both scenarios here today in these problems coming up, but they give us the actual area of a polygon. They write it as 1/2 of the apothem times the perimeter, or you can do 1/2 of the base times like the area of a triangle times going ahead and multiplying by how many triangles you have, or this one that they're showing here is actually just this one here. So there's a lot of versions of it. Again, I would say find one and go with that. And then if the other ones present themselves, maybe in some cases those are going to be quicker, so that's why they share other things, because we don't want to do everything the long way. All right, let's try it out. Enough talking. Example 3, find the area of the regular polygon. The regular nonagon is inscribed in a circle, so we know this is a center. Excuse me. The circle has a radius of 4. Find the area of the nonagon. So I'm going to go ahead and I'm going to enlarge that triangle that they're showing us here. And I'm enlarging this triangle here. Okay, I'm going to draw in my apothem, putting it with the right angle. The only things I know are that this is 4 and this is 4. That's the only given that I have. Now, if I wanted to find the area of this triangle, I'm going to need to know this distance and this distance. Those are the two things I need to figure out, right? They don't give us that. So let's think about some other things that they've given us in the past that we can use to work with. So they say it's a nonagon, which means it has 9 sides, and I can count them, and that's true. So to find this central angle, we learned before that we do 360 divided by 9, and I'm going to get 40. So that means this entire angle here, that whole angle, is 40 degrees. Okay? Now you might be thinking, why is that critical? Well, if we're trying to find sides of a triangle, we can we have a right triangle right here, right? See, we were done with triangles for little, but not for long. We have a right triangle here. We know the hypotenuse. If the entire central angle is 40 on this, and I'm just focused on this yellow highlighted red one that I'm going over now, triangle, this is going to be a 20-degree angle. Can I go ahead and use one of our trig functions? Of course I can. So again, I know I just keep drawing triangles out, but this is now, so I'm not writing over too much, this is 20. I know that my hypotenuse is 4. So with that in mind, I need to find both this side and this side. And it doesn't matter which I go with first. So I'm going to call this x, okay, to find the length of x. So from my 20-degree angle, that's my opposite side over my hypotenuse, which is SOHCAHTOA, opposite over hypotenuse, it's sine. So I'm going to do the sine of 20 is going to equal opposite x over 4. Multiply the sine of 20 by 4, and that's going to give me approximately 1.37. Okay. All right, now that's not the only thing I need. I also need this other distance here that I've highlighted. So before we go back to where we were, I'm going to call this variable a different thing. I'm going to call this one y. So to find y, I'm going to do, that's the adjacent, and I know the hypotenuse. Or I could use the Pythagorean theorem now that I know this, but this is a rounded number, so it's best to kind of avoid it so it doesn't end up rounding my next answer. So I'm going to do the cosine of 20 is going to equal adjacent y over 4. Multiply both sides by 4, and that's going to give me 3.76 approximately. All right, so let's sub these back into my this picture up above. This distance here is now 3.76 because that was my y. My x is really only half of this, and that's 1.37. So if I want, I can go ahead and double that. And again, that's a rounded value, but that's okay. So I can double that, 1.37, and I'm going to get 2.74. All right, there's a lot going on here, but basically we just kind of use some of our trig functions. Not basically, it's not easy. There's a lot. But we went ahead, we used our trig functions to find the missing values, and now we're going to go ahead and put those together to find the area of a triangle. So taking this, I'm going to redraw this triangle again, and you don't have to redraw it this many times. I just want you to be able to see what I have. So my apothem is 3.76. The base of this triangle, this entire distance here, is 2.74. So to find the area of one triangle, I'm going to go ahead and do 1/2 the base, which I know we just doubled it. So here I'm just taking half again. And then 3.76. And if I multiply all of that together, I find 46.36. And this is in, they don't specify, so just units squared. Okay? Now if I had used the formula, just real quickly, the formula was area is equal to 1/2 the apothem times the perimeter. I still would have had to find the apothem. I still would have had to find this distance, because that would be this distance, and I would have to do that to multiply it by 9 to get my perimeter. So it's just a different way of doing it, and you would get the same answer. Now that was a lot, so let's try some more, okay? You're decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon, 15-inch sides. That's convenient, they tell us that, and a radius of about 19.6 inches. What is the area? So I'm going to go ahead and I'm going to work with this so I don't have to draw the triangle kind of lopsided like above. I have this triangle. I know this is 19.6. I know that the entire base is 15, because if this is 15, this is 15, this is 15. Now I need to find the apothem so I can find the area. Well, what I can do here in this case, I don't really have to use trig. I can just focus on this triangle, right? I'll redraw it down here, just that portion. If this is 19.6, I can take half of 15 and say that this little portion is 7.5, and I can do the Pythagorean theorem, right? So I can calculate that out. So let's do that. All right, I end up getting, let me recalculate that. So, okay, so the using Pythagorean theorem again, 19.6 squared minus 7.5 squared. I take the square root of that. This is about 18.1. And that's rounded, but that's okay. So now I have all of those components. Now I can go ahead and find the area of that full triangle. So let's do that in blue. So area is equal to 1/2 the base of 15 times the height, 18.1. Okay, so I can really just do 7.5 times 18.1, and I get the area is 135.75, and I have how many triangles? Well, they told me that it was a regular octagon, so I multiply this one area, which is 135.75, times 8, and that's going to give me 1,086, and we're talking here inches, so square inches. So that's going to help me figure out how many tile I'm going to need. And that's what the purpose of this one is. Okay, now that's only one way of doing it. You could have also done our trig functions, but we're going to practice that in the next problem. All right, so we only have 2 left. Let's go ahead and find the areas of these. So if I look at the first one, it's a pentagon. They give us the apothem, they give us the radius. I need to go ahead and find this distance here. All right, so again, we can do the Pythagorean theorem, or I can use some trig function, some trig work. Since we just did one with the Pythagorean theorem, and I know you're comfortable with that, let's just go ahead and use our trig. So if we think of this entire central angle, it's going to be 360 divided by 5, right? So 360 divided by 5 is going to give us 72. I knew that. So this piece here is just 36. Okay, so I'm going to erase all that and just focus on the triangle that is drawn in. So this angle here is 36 degrees. This is 6.5. This here is 8. I want to find x. So I can say, I can either do sine at opposite over hypotenuse, or opposite over adjacent would be tangent. So either of those works. I'll go with sine. Sine of 36 equals opposite over hypotenuse. So my x value in this problem is going to be 4.7. So this distance here is 4.7. Now to find the area of that full triangle, remember I double that, so 4.7 and 4.7 is 9.4. You don't really have to double it, because now when I go to find the area of this triangle, the formula is 1/2 the base times the height, but that's okay. So 1/2 of 9.4 times the height of the whole thing, which they gave us, is 6.5. So this is going to give me the area of my triangle. Let's multiply that together. And that's 30.55. And I see that I have 5 of these triangles, so 30.55 times 5 is going to give me a final area of 152.75 units squared. Okay? All right, so now let's go ahead and do this last one, give it a try, and then we're all set. Okay, now if yours is a little bit different, possibly some rounding can cause that, and I'm doing this on my phone calculator, so possibly I even had, I was off a decimal point or so if I typed something in inaccurately, but I know the right answer, and we're there within a small range. All right, the last one. We have only 7 marked. So this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a decagon. All right, so now I'm going to go ahead and I'm going to draw in this triangle. I only know that my base is 7, so if I kind of emphasize that triangle right here, it doesn't look very symmetric. That's okay. Let's try it again. A little better. Okay, so this is really 3.5. Now, since there's 10, so 360 divided by 10 is going to give me that each central angle is 36. So I'm only going to do half of that and say that this angle right in here is 18 degrees. Okay, so I'm going to pause the screen. I'm going to fill in some stuff, and then I'll talk through what it is. Okay, just for kind of speed it up, make sure we finish it all. So all I did is that I marked this here as x, okay, and then I see that I have the opposite and the adjacent. So I use tangent of 18 degrees, working in that right triangle, equals my opposite 3.5 over x, work that out, and so I get that x, this height, this apothem is 10.77. So now I just have to find the area of the triangle, so it's 1/2, they gave me 7, times my apothem, 10.77, and all of that together gives me 37.7. So the area of one triangle is 37.7. Multiply that by 10. My total area is going to be 377 square units. Okay, we're all done. Good work, guys. Bye-bye.